Hello again and welcome to day 8 of Algebra 2 lessons with Hotard. Today we're going to be simplifying rational expressions. Currently, I have to tell you, it's getting hard to find a few minutes to make these videos. Right now I can see my children playing outside. It looks like one of them appears to be naked, but right now they're leaving me alone. So we're going to go ahead and get started. Our lesson today has two parts. First of all, we're going to review factoring quadratic expressions. We spent a lot of time on that in the fall semester. We're just going to review that because it's going to be very important for what's coming up next. And then the second half, we will be simplifying rational expressions, that's fraction expressions that have variables in them, and identify what's called excluded values. So just a quick review of factoring. Remember, always, when you're factoring, the very first thing you always want to look for is the what? Greatest common factor. Remember, GCF can be a number, it can be a variable, or a number and a variable. So in example 1, 5x squared minus 10x, my GCF here would be 5x. I could divide 5 out of everything, and everything also has an x. So when I divide that out, that's going to leave me with x minus 2. And that would be the factored form of that one. Now remember, it doesn't have to be a number and a variable. It could just be a number. And some of the problems you're going to be doing later, the GCF is just a number. Look for that first. Example 2. This one does not have a greatest common factor, so how do you factor this? Remember, I'm looking for numbers that multiply to give me the back number, add to give me the middle number. Multiply to give me -8, add to give me -2. So that would be p minus 4 and p plus 2. And the order doesn't matter, but the bigger number had to be negative, so that they had to give me a -2. They multiply to give me -8, they had to give me -2. And remember, you could always FOIL this. You can multiply this back and work it out. It should get you back to the problem you started with. Example 3, h squared minus 49. Now, this one, again, look for greatest common factor. There is no GCF here. All right, now, unlike the last problem had 3 terms. This one only has 2. Remember, if it's missing a third term, that middle term it's missing is 0. It's like a 0h in the middle. All right, so I'm looking for numbers that multiply to give me -49 and add to give me 0. So that would be what? +7 and -7. So I would say h plus 7, h minus 7. That's a difference of perfect squares because 49 is a perfect square number. Example 4. 3u to the third plus 3u squared minus 36u. Remember, what's the first thing you look for when you factor in? Greatest common factor. And what would be the GCF in this problem? 3 is part of it, 3u. They all have a u. So GCF is 3u. So first thing I'm going to do is just divide 3u out of this whole expression. All right, so one big parentheses, that's going to leave me with 3u to the third divided by 3u is going to give me u squared. Remember, there's a 1 right here, exponent. You subtract exponents when you divide. So that's u squared plus 3u squared divided by 3u is just u. Then minus 36u divided by 3u is, okay, 36 divided by 3 is going to be 12. So that can be 12u or just 12? Just 12. Now, we're not done. I'm going to factor what's left, same way I factored this. I need numbers that multiply to give me -12 and add to give me a +1 right there. There's a 1 in front of u. And so that's going to be 4 and 3. Which one's going to be positive? The 4 is going to be positive. So that's going to be 3u, parentheses, u plus 4, parentheses, u minus 3. That's a minus. So 3u, u plus 4, u minus 3. All right, last factoring problem, last review problem. 2x squared minus 5x minus 12. Now this one, does it have a greatest common factor? No, it does not. So I need to factor this, and there's still a number in front of x squared. There's several ways you could do this. If you were in my class in the fall, remember I taught you what's called the rainbow method. Here you can, when you have a number in front of x squared, only if you have a number in front of x squared and you cannot get rid of it with a greatest common factor, then you could use the rainbow method. I'm going to multiply 2 times -12, going to give me -24. So now when I factor this, when I split this up, instead of looking at -12, I'm looking for two numbers that multiply to give me negative 24 and add to give me negative 5. So just think of some numbers that multiply to give you 24. There's 2 and 12. That's not going to do it. There's 8 and 3. Yep, that'll work. 8 times 3, and I can get 5 out of 8 and 3. So they had to multiply to give me negative 24. So that means one's negative, one's positive. The bigger one has to be negative to add to give me a negative 5. So that's x minus 8 and x plus 3. Now we're not done though, because remember, last step for rainbow method, only for rainbow method, you had to go back and divide by whatever's in front of that x squared. Divide by 2. So that's going to become x minus 4. And then I cannot divide this 2 into this 3, so I move it in front of the x. That's going to become 2x plus 3. This is the factored form of that. All right, so that's basic factoring. Again, nothing new here. Now we're going to apply what we've been reviewing to rational expressions, to the new stuff. So two things we're going to be doing. We're going to be simplifying these expressions. The reason we started with factoring is the hardest part of this whole thing is just being able to factor. We're going to try to simplify what we can, and we're going to identify what's called excluded values. I'm going to talk about that in a minute. Now, before we do this problem, let me talk about what you should not do. A lot of times, every year, whenever I give this test, I always have somebody see this problem and say, okay, cross out that x squared and that x squared. The answer is 5x minus 14 over negative 4. That's wrong. Don't do that. All right, you're going to make me cry if you do that. Do not do that. All right, you cannot do that because this whole expression is being divided by this whole expression. I need to factor everything I can factor first. So let's factor the top. All right, numbers that multiply to give me negative 14 and add to give me 5, that's going to be positive 7, negative 2. So the top factors into x plus 7, x minus 2. And then the bottom, x squared minus 4, remember, no number in the middle means there's a 0 in the middle. What numbers multiply to give me negative 4 and add to give me 0? Positive 2 and negative 2. That's x plus 2, x minus 2. All right, so I factor the top, factor the bottom. Now I can cancel something out. Is anything the same on top and bottom? X minus 2's. I can cancel out the factors. They divide out. So that's going to leave me with x plus 7 over x plus 2. That is my answer. Now, I'm not actually solving for x today. We're just simplifying. We'll get into actually solving them next week. But next week, when we are solving the equations, it's going to be really important to know what these excluded values are. Excluded values, we talked about this a little bit yesterday with the graphs. There's one number you cannot divide by. What is that? 0. So excluded values are numbers that x cannot equal. They would give you 0 on bottom. Now, that doesn't mean the answer is always 0. It means what would give you 0 on bottom of your work, not just of your answer, of your work. So if you look at each of your factors before we cancel something out, what numbers could I plug in for x that would give me 0 here and here? Negative 2 plus 2 would give me 0. Positive 2 minus 2 would give me 0. So that means in this problem, x cannot equal negative 2 or positive 2. Those are my excluded values. Again, to get those, don't look at your answer. Don't look at the original problem. Look at your work. Just the denominator, the bottom of your work. What would give you 0 in each of the factors on bottom? All right, 2 more problems. Second example, same thing here. Don't try to cancel out 7x's or x squared or anything like that. Factor the top, factor the bottom. Now, how do you factor the top if there's a number in front of x squared and no GCF? You could use the rainbow method. 2 times 3, that's 6. I need two numbers that multiply to give me 6 and add to give me 7. So that's going to be x plus 6 and x plus 1. 6 and 1. Now, that's not finished, though. Don't say, yay, we're done. All right, I need to finish this problem. I need to go back, divide by 2. Divide these by 2. All right, sorry for that blip. I had to yell at my son and go change my daughter's diaper. But anyways, we had to divide these by 2 because we're doing the rainbow method. So that's going to leave me with x plus 3 and can't divide 2 into 1, so move it to the front, 2x plus 1. So that's the top factored. Now the bottom, I need to do the same thing. There is no number in front of x squared, so I don't have to use rainbow method. I just need to find two numbers that multiply to give me 12 and add to give me 7. All right, so what multiplies to give me positive 12 adds to give me 7. 4 and 3. All right, so that's going to give me x plus 4 and x plus 3. All right, now, again, anything cancel out? X plus 3's cancel. So my answer is going to be 2x plus 1 over x plus 4. That's the simplified expression. Now, again, excluded values, things x cannot equal. Don't look at your answer. Don't look at the problem. Look at your work. All right, x cannot equal, if you look on bottom, two numbers would give me 0 on bottom. Negative 4 plus 4 would give me 0. Negative 3 plus 3 would give me 0. So x cannot equal negative 4 or negative 3. All right, now, one quick thing I want to talk about before we look at the last problem. These were all kind of easy factors on bottom. All right, what if there had been a number in front of this x? What if, for example, this had factored into 2x plus 3? What would that mean for my excluded value? Then it would be x cannot equal negative 3 over 2. You'd set 2x plus 3 equal to 0, and you'd solve for x. It'd be negative 3 halves. All right, so there's going to be one or two of those type of problems in your practice. All right, last example. This one is sort of like the first few problems on the practice sheet. All right, there's nothing to factor because it's just monomials on top and on bottom. Remember, monomial is just one term, no plus or minus. So in this case, if there's nothing to factor, you just simplify the fraction. Look at the coefficients, 20 over 15. I could reduce that. I could divide both of those by 5. So that's going to leave me with 20 divided by 5 is going to be 4, and 15 divided by 5 is going to be 3. So 4 over 3. And then for the variables, x to the 8 over x to the 12, remember when you're dividing, you just subtract the exponent. The answer is going to go wherever the bigger exponent is. So that x to the 8 over x to the 12 is going to leave me with x to the 4th on bottom, because that's where the bigger exponent is. So that just reduces down to 4 over 3x to the 4th. Again, if there's nothing to factor, if it's just monomials on top and bottom, just reduce the fraction, subtract the exponents because you divide. 4 over 3x to the 4th. Now, for excluded values, again, there was no x plus something, x minus something. All right, I just need to know what number, if I plugged it in for x, would give me 0 on bottom. What number to the 12th power, then times 15 would give me 0? It'd be 0. All right, x cannot equal 0. When it's a monomial on bottom like this, with an x in it, that automatically means x cannot equal 0. That's automatically the excluded value every time if it's a monomial problem with an x in the monomial. All right, that's with no plus or minus. Okay, so try the practice problems out. All right, if you're getting stuck on something, try to factor it, and I'll give you a hint. Look for greatest common factor first. There are several problems where all you could do is factor out GCF, and then you'll be able to reduce something after you've done that. Okay, so I hope that's helpful. Let me know if you have any questions. Feel free to email me. Have a great rest of the week.